So for day 2 of our review, we're going to look at equations where the variable happens to be on both sides. With those, it does introduce different types of solutions. So one type of solution is called one solution. Graphically, this is when the two lines end up crossing at one distinct point. In the example, at the end of the problem, x is still present, and x is equal to some sort of number, be it a whole number, a fraction, a decimal, pi, whatever, what have you. It's equal to something. X is still there, and it's equal to a number. The next type of solution is called a no solution. A no solution on a graph appears to be two parallel lines that end up never crossing. X is not present, and in the end we have some sort of number, 3 is equal to some other number, but it's not 3. For example, 3 equals 301. That's not equal, we have a no solution. The last one's called not an all solution, that's how I used to refer to it. Common Core wants us to refer to it as infinitely many solutions. And on a graph, we'd have one line, and the second line would end up being right on top of the other one. So where do they end up crossing? They cross everywhere. Just like the other one, x is not present. And at the end, we have a number equal to itself. It is always some number a equal to the same number a on the other side. So let's take a look at one of our examples. 8n minus 6 equals 8n minus 11. First thing with both side equations is you can't have our variable on both sides. One of them has to go away. So I'm going to get rid of the 8n. We get rid of the entirety, not trying to break the multiplication. We're not trying to get the 8 away from the n. We're trying to get the 8n away from everything else. It's connected through addition and subtraction, so we're going to use addition and subtraction. In this case, since it's a positive, we're going to subtract 8n. The rules of equations say that anything I do to one side, it has to be done to the other. 8n minus 8n goes away. I'm left with a negative 6. The 8n goes away right here as well. And we're equal to negative 11. Right here, x, or in this case n, our variable, is gone. And we have negative 6 is equal to negative 11. That is not possible. This one is a no solution. Once again, before I get the two sides to talk to each other, I'm going to simplify. There is no distributive property, so we're good there. But there are like terms on this side. 4x and the negative 2x, because they're on the same side, we just combine them. We don't have to change any signs. We don't have to do anything. We take 4x minus 2x and get 2x. Bring down that negative 5. I'm going to reorganize this to have 8x plus 7. Now I can't have my variables on both sides. 2 is the smaller number compared to 8. We subtract 2x from this side to get rid of it, so we have to subtract 2x from this side. Negative 5 is left over. We have 6x plus 7 left over. We're down to a two-step equation. We're going to move the 7. That gives us negative 12 is equal to 6x. Divide by 6. Divide by 6. Negative 2 is equal to x. Maybe there will be a distributive property. Again, first thing I'm going to look for, is there anything on the left-hand side that I can do? There isn't. So now I'm going to focus on the right-hand side and distribute. That gives us a negative 16x minus 8. On this side we have negative 4x and a negative 20, so everything gets carried down exactly as we see it. Can't have x's on either side of our equation. Negative 16 is the smaller one, so I'm going to add 16x to both sides. Negative 16, positive 16x cancel out. Negative 4, positive 16. This is just like subtraction. If I were to rewrite it, we have 16 minus 4. And we get 12x. Still have a negative 20. Since this 12 was positive, it is a positive 12x. Bring down the negative 8. We're going to add 20 to both sides. $12x carries down. We get 12 on this side. Divide both sides by 12. And x is 1. Again, before we get the both sides to talk to each other, we want to distribute. We get 64x plus 32 is equal to negative 7x plus 32. Can't have x on either side. So I'm going to add 7x to both sides. So I'm going to add 7x. That gives us 71x plus 32 is equal to 32. Subtract 32 from both sides. And I have 71x equal to 0. Now a lot of us get tripped up right here thinking that this is a no solution or an infinitely many solution. It is neither. This is still a one solution problem. It's still a one solution problem because x is still present. X has not disappeared. He's right there. We need to get the 71 away from x. We're not trying to move the whole thing, so we're not going to subtract 71x. That would move the whole thing to the right-hand side. We don't want to do that. I want to move the 71 but leave the x. So we break the connection by dividing. And in this case, x is 0. That is still one answer. X is 0. Perhaps we have to distribute on both sides. So I'm going to distribute our numbers. We get negative 6r minus 36. On the right hand side we get negative 3r minus 12 plus 3r. Before we do anything with both sides involved, let's make sure everything's simplified. Left-hand side, we're good. Right-hand side, I can combine our like terms. A negative 3r and a positive 3r cancel each other out. And I'm left with just a negative 12. I'm going to add 36 to both sides. I get a positive 24. Let's do color. Let's go pink. Divide everybody by a negative 6. R is negative 4. Last problem we're going to look at together. Once again, distribute before you do anything else. Get rid of those parentheses. Negative 4, negative 5 gives us 20v. Negative 4, negative 7 gives us positive 28. Minus 6. On this side we have 21v. Positive 28. Combine our like terms over here on the left, we get 20v plus 22. It gives us 21v plus 28. Now it's time to get both sides to talk to each other. 20 is smaller than 21, so I'm going to subtract it from both sides. 22 is still there. 1v is still there. I'm going to subtract 28 from both sides. Left with negative 6 on the left. And since 1v, we don't technically need to write the 1. Here's our solution. Negative 6 is equal to v.